What are collisions? Explain the possible types of collisions. Develop the theory of one dimensional electric collisions. This question carries 8 marks. 8 marks in the public examination. First, the definition of collisions is a strong interaction among bodies involving exchange of momenta in small interval of time is called collision. So there is an interaction which is very very strong. Meanwhile, they exchange their momenta from one to another within a small interval of time. That means the time interval is very very less. Is called collision. The collision between two billiard balls is the example for this definition. So when these two balls are colliding with each other with a small interval of time, they exchange their momenta to each other. This white ball gives its momenta to red ball, and this red ball gives its momenta to white ball. They are exchanging their momenta. There are two types of collisions. They are elastic and inelastic collisions. Elastic and inelastic collisions. Elastic collisions. The collision in which both momentum and kinetic energy are conserved is known as elastic collision. Here, the both momentum and kinetic energy are conserved here. The example is collision between nuclei and fundamental particles. This is the example. Now, inelastic collision, the collisions in which only momentum is conserved, but not kinetic energy, is called inelastic collisions. Example: hitting a ball with bat. This is the example, and this is another example. Now, in our syllabus, we are having only elastic collision. Okay, so collision in one dimension. So the elastic collision. Consider two bodies A and B of masses m1 and m2 respectively, and are moving along the same straight line in the same direction. Let u1 and u2 be their velocities before collision. So let us assume there are two bodies A and B. Their masses are m1 and m2. Their initial velocities are u1 and u2, which is before collision. This is during collision when these bodies are colliding with each other. After collision, their velocities becomes v1 and v2 respectively. After collision, mass was not changed, but only velocity was changed, which we have to find in this derivation. Okay. Now apply law of conservation of linear momentum with this situation. The formula is the total momentum before collision is equal to total momentum after collision. So if we apply the linear momentum with first body, which is before collision, that is m1 u1, plus for second body m2 u2, is equal to after collision, the momentum is m1 v1 plus m2 v2. Okay, now write m1 values in the left side, m2 values in right side. So m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Take m1 as common, that is u1 minus v1 is equal to m2 into v2 minus u2. This is equation number 1. Now, according to conservation of Ke, conservation of kinetic energy, that is, apply the kinetic energy value with first body, that is half m1 v1 square. For second body, half m2 v2 square is equal to half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. Now write m1 values at left side. That means half m1 u1 square plus half m1 v1 square is equal to half m2 v2 square m2 v2 square minus half m2 u2 square. This is minus. Now take common factor of half m1 at left side, half m2 at right side. That is half m1 u1 square minus v1 square is equal to half m2 into v2 square minus u2 square. Half and half gets cancelled. Then this equation becomes m1 u1 square minus v1 square is equal to m2 v2 square minus u2 square. This is equation number 2. For simplification, we have to divide this equation 2 by equation 1. Divide equation 2 by equation 1. m1 u1 square minus v1 square is equal to m2 v2 square minus u2 square divided by, from first equation, m1 into u1 minus v1, m2 into u2 minus v2 minus u2. That is m1 into u1 minus v1, that is m2 into v2 minus u2. This is the denominator equation is first equation. Now cancel m1 m1 m2 m2 terms. We get u1 square minus v1 square by u1 minus v1 is equal to v2 square minus u2 square by v2 minus u2. In the numerator term is looks like a square minus b square. For a square minus b square, we can write a plus b into a minus b. So we can write u1 plus v1 into u1 minus v1 by u1 minus v1 is equal to v2 plus u2 into v2 minus u2 by v2 minus u2. So we can cancel this term and this term and these terms also. We will get u1 plus v1 is equal to v2 plus u2. Now we can write this is v1, u1 minus u2 is equal to v2 minus v1. This equation represents the relative velocity between two bodies, this before collision and after collision. Okay, we can find the coefficient of restitution also here. If these two terms are equal, that means this is equal to this, then this material is pure elastic body. Now we have to find V1 and V2. So first for finding of V1, we have to write V2 is equal to U1. This V1 becomes plus V1 minus U2. This is this is actually this is equation number 3. This is equation number 3a. Similarly, minus V1 is equal to U1 minus U2, this minus V2. This is 3b. If I substitute this 3a equation in first equation, I will get V1. So find find the final velocity V1. For that, put equation 3a in equation 1. Where is the equation 1? This is the equation 1. We have to replace this V2 with equation number 3a. So from equation 1, that is m1 into u1 minus v1, that is equal to m2 into m1 into u1 minus v1, that is equal to m2 into, here v2 means we have to write these terms, u1 plus v1 minus u2. Another thing is minus u2. Already there in equation 1. Now simplify this expression, we will get, now distribute m1, that is m1 u1 minus m1 v1 is equal to, add these two things, m2 into u1 plus v1 minus 2u2. Now distribute m2 here, m2 u1 plus m2 v1 minus 2m2 u2. At left hand side, this is m1 u1 minus m1 v1. Now we have to find v1 value. So write this v1 in the right hand side and bring remaining terms into left hand side. So here m1 u1, now bring it to left side, minus m2 u1 plus this term 2m2 u2 is equal to, write this term in the right hand side, is equal to m1 v1 plus m2 v1. Now simplify this equation, that is m1 plus m2 into u1 plus 2m2 u2 is equal to m1 plus m2 into v1. Now we have to write v1 is equal to, this is m2 m1 minus m2, this is minus m2 v v1, this is, I have to find v1, that is m1 minus m2 into u1 divided by m1 plus m2 plus 2m2 u2 by m1 plus m2. This is the final velocity of the first body v1 after collision. Now find the final velocity of second body v2. Okay. For that, put equation 3b in equation 1. Put 3b in equation 1. Then this is equation 1. This is equation 1. We have to replace this minus v1 with the equation 3b. So m1 u1, here there is a minus v1. We replace minus v1 with this u1 minus u2 minus v2 plus u1 minus u2 minus v2, that is equal to right hand side from equation 1 m2 v2 minus m2 u2 or m2 into v2 minus u2, m2 into v2 minus u2. So right, distribute m1 value m1 u1 plus m1 u1 minus m1 u2 minus m1 v2 is equal to m2 v2 minus m2 u2. Now add these two terms, that is 2m1 u1, then shuffle these terms, this v2 to right side and remaining terms to left hand side, that is that is plus m2 u2, write this m2 u2 to left side, minus m1 u2 is equal to, bring it to right side, m1 v2 plus m2 v2. Now 2m1 u1 plus, take common term u2, that is m2 minus m1 into u2 is equal to m1 plus m2 into v2. Now write v2 is equal to 2m1 u1 by m1 plus m2 plus m2 minus m1 by m1 plus m2, this which is here, this is u2. This is the final answer. This is v2 and v1 we have to prove. So this entire question carries 8 marks in the public examination. So you prepare well and write this question, answer this question in your examination. Okay, thank you.